Ahoy! Welcome to the full stack. So let's talk about how all of these different pieces that we've been learning over the last 13 weeks Lego together. So pull up a whiteboard. So, Old Man Coverly's favorite diagram. Clients request things from servers over HTTP. They get data back over HTTP. So this takes a couple different shapes. And we've seen that file servers. So I go to some URL and I type in google.com or whatever. So I ask DNS, hey, what's the IP address for google.com? And then they tell me. And then I say, hey, HTTP request to whatever that IP address is. Can you give me your index? Not looking for anything particular. Just the index is fine. And so then they give me back the contents of some file, HTML file. So client gets that back, starts chewing through it. Starts at the top, works its way down to the bottom. Along the way, it comes across other files that it needs to get. Images, CSS files, JavaScript files. So we get those JavaScript files, and over the course of executing those JavaScript files, occasionally we have need for some data. So we ask for that from an API server. We go, hey, while I was running this JavaScript that I got back from the file server, it says I need to go get some dogs. So the API server asks a database server, hey, can you go get these dogs that I'm storing? And they go, sure. And so this request is select whatever from dog. What it gets back is this sort of like tabular data. The API server turns that into an HTTP response. So that turns into dogs are this array of whatever. Client gets that back and goes, hey, I can take this array and I could turn that into an array of elements, let's say. And then the thing that's like driving this entire experience, so if this is a person using this app, they click on things, they fill out forms, they do all this. Sends HTTP requests to an API server, interacts with the database, takes stuff back, we take the data back, make stuff show up on the page, take other things out of the page. This is full stack web application development. It's a stack because all of these different technologies that you use, they fulfill roles. So you go, okay, I need something that handles my data storage. Could be anything. I need something that does my server stuff. I need something that does my client-side stuff. So the solution that we've been using, Postgres, Spring Boot. We can throw Java as part of that too. And Angular with TypeScript. We call that a stack. Give you an idea of what a different stack would look like. My home stack, like when I'm just making stuff on my own, I also like Postgres. But I use Express and Node and Vue and TypeScript, or React and TypeScript. That's a different stack. At my last full-time dev job, it was a MySQL database. It was a Laravel and PHP backend, and it was a vanilla Vue front end. All of those are different stacks. They change nothing about this diagram. All of them look exactly the same. We're swapping out puzzle pieces. How do you do this file server? And so you could even include some of that. This isn't a set thing. So if we threw hosting in there, you could say that I taught y'all Netlify for the front end and Heroku for the back end. What I tend to use myself, historically, I've used Firebase for the front end and Heroku for the back end. At my last full-time dev job, it was AWS for all of it. So it's, oh, you need a file server? How? What runs on your browser? What kind of stuff? How are you solving this application part of it there? Oh, you have an API server? How? What is it made with? Oh, connects to a database? What kind of database? All of those things together are stacks. And so it's common for a developer to go, yeah, I'm really into the mean stack. The only people who ever say that are students, by the way. I don't think there are any production mean stack things out there. But the mean stack is Mongo, Angular, Express with Node, MEAN. So see, that's the mean stack. For years and years, the LAMP stack was the gold standard. So that didn't even have a separate client technology. Everything was just generated by the server, which was using a MySQL database, and the server was written in PHP, and this is before cloud hosting, and so it became really important to specify what computer was doing your hosting. So you'd say Linux running Apache, LAMP. So that was the LAMP stack. This was the mean stack. And so you go, I'm a LAMP developer. I'm a mean developer. I feel like that sort of died 5 years ago. People don't really talk about themselves in those terms, but they do say like, oh, no, I'm a full stack developer. And they'll go, what's your stack? And like you guys would respond, Angular and Spring Boot. That is the stack of technologies you're using to solve this problem. Because this is all web apps. From like Barkwire to Facebook, they all basically look like this. Now, there may be more than one API server. There may be 50 databases. There may be like all kinds of other things, like copies of these. The fundamental architecture, though, you get your files from somewhere, you get your data from somewhere, and it runs in the browser. That's what we're here to do. Ask me some questions about it.
Where do you start? Do you start with your databases? Do you start with your HTML, your Angular? Where do you start?
Great question. So, actually, I'm going to throw it back to y'all. I'll give you like a straight answer to it, but I'm curious if anybody's been able to infer, because it's been a little subtle, but I have a strong opinion about how this should be done. Can anybody guess how I'd recommend you approach it?
Hardcode the HTML first.
Hardcode the HTML first with the CSS. Have a styled HTML page. So if you've got this HTML and CSS with hard-coded data looking exactly the way that you want, then the victory condition for having the rest of the stack filled out looks exactly the same. The thing you do first, your goal is to just keep it from falling apart. And so you'll hard code all of it, and then you'll move that back into JavaScript. So it's dynamic. Still hard coded, but pulling it out of the code instead of writing it directly in there. And then you actually model that out. So like, we'll say like dynamic JS. And then you push that back to an API. In Spring Boot, it's so easy that I wouldn't recommend hard coding it here. But when I do Express apps, I absolutely take this data that used to be hard coded here and then became hard coded in JS. I just copy it over to my API and return that data hard coded. No database, no nothing. And if I get that working, then I store it in a database. But at every step of the way, I was starting with the end in mind. I knew what it was supposed to look like. And if anything was going to break, oops, I'm not actually including the script file. Cool, you find out immediately. Oh shit, actually, that data model is a little bit different than I thought it was. Cool, now you know exactly what it is. Just go fix it. Oh no, the deployment on this API won't work. I'm missing my course headers. I can't accept cross-origin requests. Neat, it breaks immediately. Go fix it. Oh man, I don't have credentials for this database. You find out right away. Versus, if you do this the other way around, all right, I got the database working. Cool, I got it hooked up to the API. All right, it's fetching from JS just fine. And then you get it onto the page and you go, oh, wait a minute, this is the complete wrong data. That happens all the time. That's the danger of going from the back of the stack to the front.
Not necessarily going backwards, like you just said, but why not do the database first and then go to the HTML?
Because why? What is the advantage of doing the database first?
That's what you would be feeding to the HTML.
Right,
In a
but the
sense.
HTML is the boss, not the database. So the chance that you will design a table that doesn't have the data that you actually need, way higher than whatever benefit there would be to doing the database last. Because if I design this table perfectly here, and then start pushing all this stuff up to the front, or even if I do the HTML next, like second thing, then I go, oh, wait a minute, holy shit, that's not what I'm supposed to persist in here. I need a full name, but I can actually make that out of the first name and last name. It doesn't need to be stored in the database. Like you see those things there. If you've hard-coded it out into the HTML, now you know precisely which data you do and don't need. And by the time you're figuring out how to store it, that's unambiguous. You know exactly what the data, how you're using it, all of that kind of stuff. And that's the kind of information you need to design a table correctly.
Gotcha.
Now, something that I absolutely do as a part of this process, which we haven't talked a ton about yet, we'll probably talk about it more next week, I'm imagining, is data modeling. I do some data modeling like just as like a problem-solving technique. And so I might do something like, all right, I need to come up with an LMS. All right, what are my nouns in here? And so then I might say something like, all right, well, each of you has to be able to log in. So there's like a student that's a part of this. And then each of you submits things. All right, so there's a submission. And then I have to make a decision. What's the relationship between these things? Can a student have more than one submission? Definitely can. Can a submission be submitted by more than one student? Not really. So, or like, that's when I realized, oh, no. Like per assignment. All right, so now there's a concept of an assignment. Okay, so how does that relate to the rest of this? And I go, all right, an assignment or a submission is for a specific assignment. Like a submission can't be for more than one assignment. But an assignment can have more than one submission, like from different students and stuff. So that process is called data modeling. And like I didn't make this up. This is called crow's foot notation. You're figuring out what the big parts, the entities in your application are, and then figuring out how they relate to each other. But I'll go right from here into the HTML and CSS because seeing this relationship, like that gives me a lot of information that I need for the interface. You go, okay, a student can have many assignments, an assignment can have, or sorry, a student can have many submissions, assignment can have many submissions. So that means a student can have can submit more than one assignment, and an assignment can be submitted by more than one student. All right, that checks out. So then I go right into this wireframing exercise that you guys were doing like week 3. So then I go, all right, well, how would I model that out? Or sorry, how would I make an interface for that data that I just modeled? So maybe that's something like, okay. So maybe I've got students across the top, and then I've got each assignment down the side, and then each instance of a submission. I guess that's like kind of at the intersection. And so that would be like, all right, we got that, and we got that. All right, I'm going to hard code an HTML table with all this data in here. I'm going to style it. I'm going to get it looking right. And then I'm just going to push all of that data back through the stack. Another reason to do the HTML and CSS and stuff first, this helps you at least, the process of moving backward, figure out what if this data is actually just part of the interface? It's not, doesn't need to be saved anywhere. Should be hard coded in the HTML. Like, are there headings or something like that? Do those get stored in the database? Probably not. So, but yeah, I'll start with something like this and then try to use that to inform, all right, how am I going to represent a relationship like that in a wireframe? And then I'm going to try to take that wireframe and code it up as HTML and CSS. And all right, what if this data is dynamic? Start moving that back through the stack.
Stupid clarifying question. When you say HTML, CSS, do you mean that or like in an HTML, CSS file or
Yep.
in an Angular framework already?
Or whatever. Like, just however it's going to be presented. So
Okay.
if I'm early on in an app, yeah, I might just do HTML and CSS pure. And then maybe I make a feature or a landing page or something like that. It's the first time I really need something that would be like an Angular app. I go, all right, fuck it. This is getting too complicated for vanilla. And so then I'll scaffold out an Angular app. It's not like all HTML is, with like a very minor asterisk, all HTML is legal Angular HTML. Just copy and paste all that HTML over. Same thing with the CSS. Just copy and paste it over. And like, you're probably not too far along by that point. But yeah, whatever the view is coming from, do that all hard-coded first.
Now I'm curious, what's the asterisks?
Call span. It is an attribute of a table element that crosses more than one column. There's an attribute in HTML for that called call span. I think in regular HTML it's all lowercase, and in Angular HTML it's camel case. I think that's literally the only one.
Gotta be different somewhere, I guess.
Dude, like, okay, so in React, it's so much worse. So JSX, which is React's like HTML dialect, you can't use all of it. In JSX, all JavaScript is like legal kind of anywhere. And for that reason, you can't use the word class because that's a keyword in JavaScript. So when you're setting the class of an HTML element, you have to use class name. That one drives me fucking crazy. Also, the word for, well, that's how we do loops in JavaScript. So label can't have a for attribute. It has to have an HTML for attribute. And there's two more, so like good luck finding them. Yeah, all of them are a little bit different.
Very fun.
More questions about big picture on this?
So a couple different people online suggest like when you're styling an app, do mobile styles first.
Mm-hmm.
But I've never done that before, so I've never really seen the benefit of it. What do you think?
I don't think that needs to be a hard and fast rule, and I'll explain why. But it's not bad advice, and here's why. So at your smallest breakpoint, you basically no longer have access to the horizontal axis in your design. It's just stuff stacked on top of each other. Because if you've got a 3-inch screen, it doesn't go, there's nothing you can do left to right. So what that makes you do is stack things on top of each other. And you go, all right, it's this. You have to make decisions about what's more important and how things are prioritized. And what this, whatever your thing is, looks like on one dimension. That's easier than figuring it out on 2 dimensions. So that's a pretty smart place to start. And in the process of figuring out what that looks like you end up with a lot of very useful information for when we have 2 axes that we can play with. As you go, Okay, well, these things are important in this order. Huh. So how do I work with that on 2 axes? So maybe these 3 things, maybe I could do that something like this one goes across and then these 2 are subordinate to it. Like that. And then these things are like roughly equal, so maybe they're kind of more like that. And then maybe that's what your 2-dimensional layout sort of looks like. And if you have all of these boxes and they're kind of styled and stuff, you can use something like flex or grid, like flex order, or like assigning things to grids with media queries to go, okay, cool. Well, this whole like thing works all right there. So I just need to figure out how to move that there, and that there, and that there whenever that breakpoint gets hit. That's why that's a pretty decent strategy for figuring out a layout, because you start with the easiest stuff that makes you make some tough decisions that are useful for you when the interface gets more complicated. Now, here's the reason why this doesn't need to be a hard and fast rule. Each one of like your main like interface adaptations still needs to be individually designed. If you've got a super solid idea for the desktop version of it, cool. Maybe like you can take the information that you have there and it's easier to go the other way and break that down. But there's no world in which you can just automatically do something like this and get either a mobile layout or a desktop layout. So one way or another, you are still going to need to do the work of like drawing squares and figuring out what all this stuff is. And maybe your tablet one is like that. That design work is still going to need to happen regardless. I don't know that it's a hard and fast rule that one of them gives you any advantage over another one in every circumstance. But I really don't think that's a bad instinct and definitely has some advantages.
So when it comes to the whole JavaScript and JavaScript dynamic portion, when we're getting like these objects and arrays put together, like what the API is going to look like, is it better for us to build out, this is all the data that my final project is going to work with, or would it be more beneficial to say, here's a few drink recipes and I'll put the rest in later because I know that it's going to be dynamic?
So, who can answer that question based on what we've talked about in the course so far? Same thing, it's a little subtle.
My
Looks
guess
like you
is
have.
later, but
Why? Who's got some insight on that?
Because you want to get it working in small chunks.
Small chunks. There was a specific phrase that I used for that.
Slice.
Starts.
And vertical slices.
Thin vertical slices. So if my app is database API client, the way that I want to develop this and the way you want to develop your capstone isn't, oh, what's all of my app? Well, I should do all of the database work for that. That's a fat horizontal slice. That's not what we want at all. What we want is just enough client, just enough API, and just enough database to get one feature working. And then we get that feature working. It's ready to deploy. Maybe that is your capstone. Then you do another one. Hey, cool. It's only Wednesday of the first week. Maybe you do another one. Oh, that one sucked. No, this is going to be too hard. Cool, start another feature. You're not out anything. There's nothing you need to tear apart. Just go back to how it was when you were doing this. All right, and then I add another feature. And then I add another feature. And then it's Wednesday, Thursday, second week. Oh man, I'm getting my butt kicked on this. Whatever, didn't work out. So we get rid of that code, And then you're presenting 4 complete features. 0 panic required. No, I have all the database done. I have all the API done. I just haven't done the client yet. Well, oops, that's the most important part. That's what your user's interacting with. If you don't have that, you don't have an app. No one cares that you did all this cool API work and all this cool database work, but nobody can work with it. That means, from a lean sense, all of that extra work over here, that's all waste, because it's for a feature that we can't ship. We do this, we're only doing enough for that feature so that we're taking all the stress out. Maybe our grand dreams the first day of Capstones, this was going to be 10 features, but I only got to 4. If it's 4 complete features, who cares? That's 4 complete features. If it's 80%, if it's 99% of a working app, it's still not 100. That's 100% of a working app, just a smaller one. More questions about this? Stacks, the big picture, how it all fits. Full stack web application development. Type in a URL, look up an IP address, ask for some files, chew through the files. When you take some action that causes you to need more data, like navigating to a page, we ask for the data from an API server asks a database, data comes back from the database, data comes back to the client. We make DOM elements, we take DOM elements out, user sees a different page. That's what we've been doing for 13 weeks. You go to lms.sikaeducation.com. You hit Firebase, no, this one's on Netlify. You look up the IP address for Netlify. You probably already have it if you've been to anything else that's hosted on Netlify, so this DNS is still in your computer. You go, hey, give me an index.html file. You get that back. Oh, I need a CSS file too. Cool, you ask for that, you get that back. Oh, I need this in JavaScript file. And the file server goes, oh, it's a doozy. It's like a megabyte big. It's huge. It's a full React app. And so you go, cool. Well, here you go. Browser chews through this, fires up all that cool stuff you see. And then it goes, hey, you need to log in. And so you click on that button. And there's another API server. I don't run it, but it is otherwise the same kind of thing. There's a server provided by a company called Auth0 that does our auth. So you request something from them. They request, hey, GitHub, this person who just logged in, are they who they say they are? GitHub goes, yeah, they are. They're good. So this comes back to my application. My application is chewing on this. And then it goes, okay, cool. So this is John Lake. Give me all of John Lake's submitted performances. While you're at it, go ahead and give me all the curriculum also. And so then John Lake's browser makes a request to Heroku, who holds the CKLMS API, and goes, hey, can you give me all of John Lake's performances? While you're at it, I wouldn't mind all of the curriculum stuff too. All that stuff stored in a database. So we pull that out of the database, comes back, sends it back here as just an array of performances and what have you. and your browser chomp, 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 makes a bunch of HTML elements out of it. And then that turns into, come on. I don't see all of them anymore because it was lighting my computer on fire. But all this stuff. Which, hey, that kind of looks a lot like that. Weird. Your JavaScript does all the logic for, oh, John Lake has 2 performances for this. And then the JavaScript goes, cool, which one's more recent? Well, let me look at this one property. So it sorts them. All right, this one's more recent. Was it a pass or a miss? He goes, oh, it's a miss. All right, if that's the case, render this red X DOM element. Oh, never mind, it's a pass. Cool, then render this green check mark DOM element. Web applications. Ask me some stuff.
Cal, do you live right by a fire department?
Like across the street.
Okay, I was always wondering because I'm like either there's like really major stuff going right by you, or you live by a fire department.
No, if I hit a home run out of my backyard, it would blow out their window.
Nice.
I would say I'll know to look out for that next time, but I'm raising my kids in this house if everything goes according to plan. So, oops. So let my pain be a warning to you. Maybe check how close to a fire station you are.
This is kind of off topic, but not really. If we wanted to authenticate with GitHub for our capstone, is that outside of the scope for this course, you think, or could we do it?
Like, you could probably figure it out. Many people have before. I don't know how you do auth in Spring Boot. It might be pretty easy. I'm sure they have like a starter for it. So time leaf, by the way, that's rendering HTML with Spring Boot instead of like bringing data back. You can also have Spring Boot just generate HTML for you. Why couldn't you? It's just characters. So that's how all web apps used to work. They didn't have this separate API part. It just sucks for a couple of reasons. But all right, Spring Security. All right, so that has a starter. And then the setup for it. So that's username and password. I'm sure there's like some config there. So GitHub uses a thing called OAuth, or Open Authentication. It's a valet key system. So you guys try to log into Sika, and Sika goes, I don't keep track of who anybody is, but I trust GitHub, and you trust GitHub. So if you log into GitHub, I'll ask them, hey, they're trying to get in over here. Is it cool if I have some of their stuff? And then you get the thing going, hey, by the way, Sika Education really wants to get your email address and your name. And they go, you cool with that? And then you go, yeah, give them a valet key to my account. A valet key only goes 3 miles or whatever before it shuts down. In my case, I don't actually have real access to your account. I have access to your name and your email. I can't make repos on your account or do anything else. So GitHub gives me a valet key to your account that gives me the 2 things that I want. And then I just have those in JavaScript now. So I could add those to my own database. I don't, but I could. I just use it to attach your email address to your submissions. And other than that, there's no concept of like a user in my app, actually. What else? All right. Hopefully the full stack makes a little bit more sense now. Actually, one more thing. I'll try to make it quick. How about I try to request something from that API we built this morning? All right, so I hop out of the Barkwire lesson. I do something like npx angular CLI Barkwire lister. All right, so this makes me a new Angular app. How about no?
While that is installing, I have a quick question.
Yeah.
Remember our projects that we did for our 6 weeks project before we got into here, our profiles and stuff? I remember we had to show our creativity page.
Oh, yeah, something like that.
Okay. Well, my creativity page was about a website I would like to build if I knew how.
Uh-huh.
Can I use that, or is that restricted?
Fine with me. I like the symmetry of that.
Okay.
All right, Barkwire lister. All right, so I have a fresh Angular app here. I'm just going to go ahead and fire her up. And then I'm going to try to make this as quick as possible. So I'll just make a service real quick. npx ng generate service dog. Make a dog service. Then over here in my app component HTML, bye. Cool. So if I, oops, it's not 8080 for this one. Is it 3000? 420? 420. Yeah, there we go. All right. So, all right, so I've got that showing up. Now I just need to make that dynamic. So over in app component TS, we do something like dogs is an array with Sometimes I'll make them a little bit better, a little bit different, like chow chow to chow, just to see whether, like, when the actual change happens. Then over here, I could do something like, all right, this is an ng4 let dog of dogs, and that's dog.name, dog.breed. Cool, worked. So now I want to keep pushing this back. So what if I put that in a service? So over here, I could say, I'm going to make that a property of the service instead. And then over here, I can make a constructor and inject that service. So that was private dog service is a dogs. Yep, had it. Is the of the dog service type, and then I can also have like a dogs thing that's a of the dog array type. Man, I'm gonna have a heart attack going back and forth between these two different type systems. Oh, it doesn't know what a dog is. That's fine. I'll just say an array. No, I need to have a dog type. All right, so I would generally recommend keeping your types separate from your services. It'll be fine for right now. Okay, so I import that type. And then all right, back in business. And now I'm not seeing anything because it's not actually getting it out of the service yet. So I can do like an ng on init over here that says this dot dogs is this dot dog service dot dogs. Cool. Slowly moving this back the stack. Gradually, a little bit more dynamic every day. I can also add the interface for that. Implements on init. Cool. So then over here, maybe I make a get dogs method, because like right now it's all happening synchronously, but it's not actually synchronous. So there is a built-in tool for RxJS where you can just make something that's a static value and observable. It's called of. So we can say like of this dot dogs, and then otherwise like do the same kinds of things that we would normally do. So that turned dogs into an observable. So then I can do something like get dogs dot subscribe, and then take the dogs that I get back and say this dot dogs equals dogs. Still working. Still working. So now, when this becomes an actual observable, like an HTTP call, it all still works the same. Let's check that it does. I need the HTTP service in here. So this is going to be private HTTP, talk me through this. It's been a second. It's HTTP client. And then I need to also bring that into app module. So this will be HTTP module.
Client module.
Client module, thank you. HTTP.
Does it have to have common in there?
It's common / HTTP.
Thank you.
I think I'm doing it from memory at this point.
Yeah, it's common / HTTP.
And take off the / HTTP client module. It's just Angular, common, HTTP.
Right.
And then you need to go put it into imports underneath the browser module.
That makes sense. All right. So now I have the HTTP client module in there. If I go back to my service.
You need to import HTTP client.
Oops. Oops, because it's actually that. There we go. All right. So now instead of hard coding this, I'm going to this.http.get. What was the thing from this morning? Barkwire lesson. Barkwire dash lesson API dogs. Wakes up that server. Come on. So if I return that instead, okay, cool. Oh, I need to tell it what comes back from this. So there's also going to be a type dogs response, which comes back with a dogs key, which is an array of dogs. So then I can say the thing that comes back from this is a dogs response, which is helpfully telling me that, hey, I got a type mismatch. Because now this needs to be response. See how it's telling me like right away that there's a problem. We like that. And now, holy shit, I have a full stack app integrating with the API from this morning. That's full stack application development. That's what we do. Questions about any of that? All right. I hope the picture is a little bit clearer than it was this morning. Okay, let's survey out and feel and get the fuck out of here.